Hi everybody! In today's episode I'm going to recreate the game Snake in Java. If you're a dinosaur like me, you might remember this game from 1990. It came out with MS-DOS 5, I believe, Microsoft Disk Operating System. This is the first episode in the series where I'm building functionality gradually until we have a full game. So, let's go. I'm going to build the game in text mode, just like the original. So for this, we need two things. We need to first capture the keyboard inputs as they come in without pressing enter or waiting for a line end. And we need a terminal to write text to a certain position in the window. These two are already troublesome for Java on a Mac, so let's see how we tackle these problems. This console class from Washington University, it's gonna give us a terminal of 25 rows by 80 columns where they actually simulate a terminal. Well, the good part is that we can actually write to this terminal at a certain position on the screen. So for this we're going to use this class, we're going to put it in our project, and we're going to use this put string at, which accepts a string to be output and a row and a column. We're going to use also the print screen method after that, so all the changes that were done on the screen buffer will actually be printed out. For the other problem, reading the keys that the user presses, by default Java expects the user to type in the characters and press enter, and only then that the input is available in the system in. This means that the terminal is in line mode. This is not good enough for us. We need to change it into what we call a character mode. So then the characters that are pressed and they are typed are available immediately in the system in stream. For that, we're going to use these two methods to change the terminal mode. So when the program starts, we're going to put the terminal into character mode, and just before exiting the program, we'll put it back into line mode. We're going to write our game just in a simple class for now, where we instantiate the game object in the main. And in this constructor, we're going to put, for now, all the logic. So we don't actually need snake game. It's enough to do just a snake game. And these two methods don't need to be static anymore. And we're going to call them from the constructor. Let's try something like this. First, we put the terminal in character mode. Then, try finally block just before exiting the game. We're going to put it back in line mode. Of course, we need to catch some exceptions here and handle them, so let's see what we do. Let's just leave it like this for now. So let's try read some input now. Okay, so in this method I'm reading keys pressed if they're available in system in, and as they are being pressed I'm going to record them into the key pressed string, but I'm going to read them as characters. So let's see how this works. Let's do a while loop here. Let's call it while it's running. So while the game is running, do these key presses. So while the game is running, read these key presses. Of course, we need to create is running as a field. For now, leave it to true. Give it a pause here of, let's say, 1 second. Define the method pause. So this pause method just calls the thread sleep. Now we need a way of outputting those key presses to see what we have. So let's try the simplest system out key press. I don't think this will work nicely because now the terminal is not in line mode anymore, it's in character mode. So I don't think the print line will actually put the caret back in the beginning, but let's see what happens. And clearly this will run forever because is running will not ever go to false. So let's see what's happening. We're going to run this in a terminal, so oh, it's registering something. It's registering more than one character. Let's see how it registers arrows. Ah, the arrow is not registered, or not yet. 1, 2, 3. Okay, what we want to do is read the arrow keys as well. Now, Control C doesn't work, so I actually have to kill the program now. So now let's modify this method to actually read not the characters, because I think the characters are some special characters when I press the arrow key. Let's read them as actual ints. So for this, we're going to add the int to the string, so that the concatenation will actually make the int a string. So what I'm going to have here is basically the ASCII codes of each character that I type. So let's see what happens when I press an arrow key. Aha, that was a up, right arrow, low, down arrow. So what happens here, actually, it seems like there's 3 characters which are being sent to the terminal when I press an arrow key. First one is 27, then 91, then 65. So let's first do a initial key press handler. So in case we press escape 24, let's make this is running false, so then the program will actually exit. So what happens here, we switch the key pressed string, and in case it's 27, this is a string 27, then we stop the program. There's a problem, of course you cannot assign something that's final. Okay, now it's good. So let's run it. We press key 1, 2, 3, Q, W, E, and we press escape. Ah, there. So escape works. Good. Now let's consider the first problem solved. We have now inputs. So next we're going to see how we can put something on the screen at a certain position with the terminal. I put those calls in a do loop method, and this will be actually the loop of the game. So it will repeat over and over until you either win or you lose the game or something happens. Let's create a new console. Let's initialize it in the constructor. Let's also initialize this is running in constructor. And now let's output something on the console. So what I'm doing here is I'm going to output the key presses to the position 1, 1, row 1, column 1, and then I'm going to print the screen. There you go. We have the key presses, and they are positioned at a certain location on the terminal. But they are not being deleted or erased. So probably I would need to put something here like this. Just output a big space after them so that they are deleted if a longer one has been there previously. Okay, so we have now a terminal where we can output things at a certain position. We have a way of reading the inputs and seeing which key has been pressed. So now, next thing I would do is create a very little dot on the screen, which I can control with my arrow keys, which goes up and down, left and right. So let's just simply create a position of that dot on the screen. So we're going to give it an int x and an int y. For now, let's just initialize them with some hard-coded values. The terminal is 25 by 80, so let's put them right in the middle. And what I want to output is always a little star. So I'm outputting a little star at the X and Y position. Now I need to modify those X and Y according to inputs on the keyboard. So I need to intercept certain keystrokes in order to change a direction in which this dot will move. I don't know the code, so let's try run this code to see what the codes are for arrow, let's see, arrow up. 279165 is arrow up. Let's do down. Down is 66. Left 68 and right 67. And there's the dot we have in the middle. Okay, now the dot needs to move. So for that we'll give it a direction, and we're going to change the direction according to what keys we press. So initially, let's give it a direction of going right. I don't know, let's just give it a direction. So 1 is up, 2 is down, 3 is right, 4 is left. So I would say 3. So here in the handle key press, we're going to change the direction accordingly. Now we need to calculate the next position. So let's just call it here. Calculate next state. So in this state, we're going to look at the existing X and Y, the direction. I'm going to update them accordingly. So let's just do another switch on the direction this time. So if the direction is up, what changes in the position? Well, Y decreases. If it goes down, then Y increases. X increases, and for left, X decreases. So every time the loop is executed, we're going to read the keys, handle the keys. This will set the direction. We're going to calculate the next state, and we're going to put the character at the new state. Well, let's see how this works. We are missing a step, but let's see how that is handling it. So let's press down. It's going down. Let's press left. It's going left, up, right. Okay, so it's moving. One thing that I don't like is that it doesn't move the actual dot. It actually just creates extra dots, extra stars. So let's take care of that. So here, before we calculate the next state, we need to remove that dot and calculate the next state, and then output the dot at a new position. So actually, let's just copy this. And we're going to put a space where the dot has been or is currently. Then the dot moves, the position moves, and then we output the dot at the new position. And then we print the screen, so we actually show the terminal. And there it moves. So now we can go up, and we can do all the changes. Perfect. Let's just make a bit of a cleanup here. So we can put this method in it. This line is in its own method. I'm going to call it paint remove. So I think this makes sense for now. We have the loop, we have the key presses, we read the directions, and we are printing out a star which moves according to the key presses. We have made a bit of cleanup here, so we have the methods ready to work on this further. So I think that's enough for the first episode. I'm going to end this video here for now. So I'll see you later to add more functionality to this guy. So we have a working prototype now. Of course, this is not by far anything final, so at least we know we have something working. So I'll leave it here for this episode, and in the next episode we're going to add more functionality and we're going to clean up the code a bit, because you cannot have everything in just one class in just this type of format. So thank you for watching, and I'll see you in the next episode. And if you find this interesting, please give it a like, subscribe, and ring the bell so you get notified next time I upload a new video. Bye for now.